Could a black hole devour us all one day? There are millions of them out there just waiting, and if we happen to make a black hole accidentally, well, you better fasten your seatbelts. Things are really going to suck, literally. What would we see if we got pulled into a black hole? Could Earth orbit the sun in a black hole? And would we survive spaghettification? This is what if, and here's what would happen if Earth were sucked into a black hole. Just 3,000 light-years from Earth is a black hole visible to the naked eye. Thankfully, we're a safe distance from this stellar black hole and many others like it. There are approximately 100 million of them out there in our galaxy that we know of. They are remnants of supernovae, which occur when stars 10 to 20 times larger than our sun collapse in on themselves. Stellar black holes are fairly common and are about 16 kilometers in diameter. And then there's the much larger competition, supermassive black holes. These have a diameter roughly the size of our solar system, and a mass greater than 1 million suns combined. One of them, known as Sagittarius A, is right smack dab in the middle of our galaxy. So how close would a black hole need to be a danger to us? Well, technically a black hole the size of a 1 millimeter pin could destroy us if it was close enough to Earth, due to its incredibly dense mass and extreme gravitational pull. Our survival all depends on whether we've surpassed the event horizon or not. You can think of this as the black hole's point of no return. If Earth got close enough, the side nearest to the black hole would begin stretching toward it. Our atmosphere would start to be vacuumed up, and then huge chunks of the Earth would rip apart and follow suit. If Earth managed to fall into the orbit of the black hole, we'd experience tidal heating. The strong, uneven gravitational pull on Earth would continuously deform the planet. This would generate a tremendous amount of internal friction, heating the Earth's core to disastrous levels. It would likely give rise to earthquakes, volcanoes, and deadly tsunamis, the trifecta of doom. Eventually, Earth would begin to stretch in a process known as spaghettification, and not in the tasty, cheesy, tomatoey way. Let's say you were a superhero and decided to fight the black hole head first. Well, your arms would be closer than your feet, causing your body to stretch out vertically and become more and more compressed. For an average-sized stellar black hole, spaghettification can occur several hundred kilometers away from the event horizon. But for a supermassive black hole, physicists believe that this would happen inside the event horizon due to its size. Eventually, no matter what size it is, anything entering a black hole would be ripped into a string of individual atoms. This would happen to anything that crosses it: people, planets, stars, you name it. What we do know, however, is that that's a story for another what if. Black holes come in more shapes and sizes than you might imagine. Let's take a journey across the cosmos to meet the four main types, and discover just how strange and varied these cosmic monsters can be. First, meet the stellar black hole. These are the most common. The remains of gigantic stars that have run out of fuel and collapsed under their own gravity. Imagine something with the mass of 20 suns squeezed into a space just 16 kilometers wide. Stellar black holes are scattered throughout our galaxy, lurking in the shadows, sometimes even paired with a companion star, feasting on its outer layers. Then, there's the supermassive black hole, the giants of the universe. These titans sit at the heart of nearly every galaxy, including our own Milky Way. Sagittarius A, for example, has a mass equal to 4 million suns, all packed into a region smaller than our solar system. Scientists are still unraveling the mystery of how these monsters grow so huge, but one thing's for sure: their gravitational pull governs the dance of stars and planets for thousands of light years around. But the universe has more surprises. Intermediate black holes are the cosmic middle children, neither small nor truly massive. Ranging from 100 to a few thousand times the mass of our sun, these elusive objects are harder to spot. Astronomers think they may form when several stars collide in dense star clusters, but so far, only a handful of candidates have been found. And finally, we journey back to the dawn of time. Primordial black holes are the stuff of theory. tiny black holes that could have formed in the chaos just after the Big Bang. Some might be as small as an atom, but with the mass of a mountain. If they exist, these ancient relics could help unlock the secrets of dark matter and the early universe itself. So whether they're born from dying stars, lurking in galactic centers, hiding in clusters, or forged in the fires of creation, black holes come in many forms. Each one shapes the cosmos in its own mysterious way, and each one is a reminder of just how strange our universe can be.